Okay, our next speaker is Judith Joyce with EarthView Environmental. Judith is founder and president of EarthView, and she is a geologist and certified professional wetland scientist with over 20 years of experience with wetland science, soils, and geomorphology. She specializes in soil characterization, plant identification, and hydrological studies with an emphasis in soil interpretations for land use planning, and has worked closely with a variety of both public and private entities and organizations throughout the Midwest. She's actively engaged in many projects at EarthView, including wetland delineation, mitigation, monitoring, stream bank stabilization design, and land development suitability evaluation. Judy prides herself in being active in the community. She has provided workshops around the state for all ages on wetlands, soils, wastewater treatment, and integrating natural areas back into communities. She's involved in community outreach projects and currently serves as president of TAKO, Take a Kid Outdoors, whose mission is to immerse participants in enjoyable activities so they develop an attitude of appreciation and respect of our natural world. So with that, welcome Judy, and we're looking forward to Beyond Designs and Drainage Reports.
So one of the things we run into is, I always come out of these conferences looking at all these beautiful pictures, thank you. And then I go back and I look at some sites, and I'm always disappointed when I look at some Stormwater BMPs that aren't as beautiful as they look in the picture. So if you look, okay. So you guys have seen these. If you haven't seen some of these, beautiful BMPs, lovely flowers, water levels perfect, just like you want a beautiful garden in your backyard. They always show pictures of butterflies and kids playing with them, and again, how this is a great amenity to your neighborhood, which they are. And then, in reality, a lot of times you go out and your BMP looks like this. Anybody have a BMP in their neighborhood that looks like this? Right? Used full of trash. Water level's not right, or perfectly mowed grass. Which again, if we're looking for water quality treatment, as Chant has mentioned, the grass, the turf mix is not giving us the best benefit for our buck. If we really want to treat that water, we want something that's going to have a little bit more integrated root system that lets that water migrate through the soil profile. So when I see things like this, I think these are really missed opportunities. When I was a kid, I'd still play in those, looking for frogs and stuff, but it isn't the pretty picture that you're going to see of kids playing in the Stormwater BMP. And when you see these, especially right after construction and the plants don't come up, it's really common to just want to blame. Who messed up? Did that landscaper not plant the right thing? Was it not designed right? Oh, it's a contractor. He wasn't supposed to compact the soil, and everyone's looking for somebody to blame. Is there a warranty on this thing? And then you look at it, it's like, we followed all the right steps. We designed it right, we looked at the manual, we did our calculations, we did our drainage report, we used the tables out of the manual of what to plant, and we did all of that. We looked at the soils, and we followed our construction documents, and everything was constructed right, so what went wrong? And what I found is that the number one reason for failure is that there wasn't a good or an adequate understanding of the hydrology of the soil and of the vegetation. There wasn't a good understanding of how a natural system works. And we find this in BMPs and in our wetland mitigation sites. is that if there's not a good understanding of the soils, if there's not a good understanding of the hydrology, then the plants don't get established. Then it's doomed to fail. So what I wanted to go through today was basically some additional steps, or maybe reevaluate some of the steps that we're taking when we design a BMP, and walk us through this. And rather than me just going through this one after the other, I'm going to do a case study. And there's many different things I could throw in, but we're just going to focus on this one case study for Webster City. So Webster City, anyone been to Webster City? Anyone here from Webster City? Yeah. Boone River, beautiful water trail up there, right there on the Des Moines Lobe. They have wanted to build a stormwater wetland, and we've been working with them for the past 6 months or so with HBK Adrian Homes, and so I'm going to walk you through that project. So I'm going to say step one is to work with a qualified professional. And this is going to be specifically what I'm talking at this step is when you look at the soils and the hydrology. So, you know, who is a qualified professional? You know, do you need to hire a professor at a university? Do you need to hire a geologist? Do you need to hire a wetland scientist, a soil scientist? Who is this person? Who is this magical person that you can hire who will give you the information that you want? And in other states, in their rules, they've actually defined this, or they have a licensing entity. Similar to the way we have licensed engineers, they have licensed soil scientists, or licensed environmental scientists, or licensed biologists, or licensed geologists. In Iowa, we don't have that available to us. So this is actually from, I believe, Wisconsin, and this is what they require. Again, that you have to be a licensed professional. What my rule of thumb is that you want someone qualified who understands how a natural system works, who understands the relationship between hydrology, soils, and vegetation, and has a good understanding of the technologies available to you and to what the design options are. So to me, this is the person you're looking for. So once you find a qualified person, the next job is to characterize your watershed, and the manual actually does a pretty good job of this. Again, if we look at Webster City, one, you want to understand where you are in the world, right? We're not on the East Coast, we're not in Las Vegas, we are in Iowa, and we're on the Des Moines Lobe. And water moves a little differently on the Des Moines Lobe than it does in the southern Iowa drift plain, or than it does in northeast Iowa. So again, understanding that I think is very important, understanding where you are. You also want to understand what your current land use is, where your BMP is going to go, what the current land use is around you, what the quality of stormwater is coming to your basin. Is this from farm runoff? Is this from an urban area? Is this from an industrial site? So you really want to understand what the activities are in your watershed and how water moves through it. So if we look here at Webster City, this is the town of Webster City. The Boone River runs down over this way, and where our BMP is going to go is what's known as Riverview Park. So you can see it's right adjacent to the Boone River and this structure here. This is the railroad berm through here. So we're going to use the railroad berm as a marker, and then the Boone River as the marker. Okay. Here's a little bit different picture, looking from the east going to the west, and there's currently 2 storm sewers pipes that come from the town to the Boone River. Basically, it's just piped straight through, and what the city wanted to do was to intercept that water and treat it again through a wetland system. So that was our goal. Step 3, site evaluation and soil analysis. So what's that? I get this a lot of times. Like, again, it's not extremely well defined, right now in Iowa what to include in a soil analysis, what details to look for. So not only do we know who do we hire, we don't know what to expect. Is this a modeling project? You know, what information do you need? So before I go into that, I'm going to go over some definitions just so we're on the same page. First, natural systems. I'm going to use a wetland here because a lot of our BMPs mimic wetlands pretty well. But basically, if you look at this, your water comes from the uplands. It comes into your BMP or into your wetland. It infiltrates into the soil, and when that water moves through that soil, there's particles that nutrients can attach to. There's bacteria, soil bacteria and microbes that will eat things that will make us sick. And it'll also cool the water so that water, if it's hot coming in off a parking lot, it'll cool the water as it moves through that soil profile. And eventually it slowly meets the stream. Okay? In a large flow event, it will bypass the system and it overflows, and you can see that to the back. It would overflow and go directly to the stream. So our BMPs are pretty much set up this way. And in a natural system, the plants that are growing in here are adapted to that environment. When we talk about what I'm going to call infiltration systems, these are systems that rely on the soil to treat the stormwater and also to let that water be dispersed through the soil profile. So infiltration systems treat with natural undisturbed soil and then let it go through the soil for final dispersal. I'm going to call that an infiltration system. Then there's a filtration system. This is typically when we make an engineered soil full of compost, sand, topsoil, you mix it together, you make an artificial filter, basically an artificial soil. You let the water go through it, it filters, and then after it filters, it can infiltrate into the soil if the soil is acceptable to that, or if the soil doesn't allow it to infiltrate, then it can exit the system. So with a discharge point for final dispersal. Okay. When we start our site evaluation, you're going to look at all these factors, and what we're trying to find out is that soil adequate enough to treat that water? That's our ultimate goal, is will that soil accept that water and accept that water over time and continue to infiltrate over time? Because if it doesn't, then it's going to back up and your site's going to be flooded out. And if you haven't accommodated for that with some sort of overflow, you're going to flood out your site. Does that make sense? Yes. So let me show you here. So what we did is, we're looking here at Webster City, at River City Park. Here's what it looks like. It looks like a city park. It was a campsite, big large trees, mold turf grass. We looked at the soils, we looked at the site. And typically what I've seen is when you look at the soils, you go to the soil survey, you look at the soil survey report, and that's it. That's the end of your soils research. You've looked at the soil survey. And in this case, the soils looked like they were sand, sandy loams, sands and gravels. So will this infiltrate or will it not infiltrate? Will it hold water or not hold water? Do we know? How many people think it'll hold water? How many think it won't hold water? How many people don't know? All right. So really, until you go out there and look at it, you don't know. You don't know how this is going to act. You know, the soil survey is designed for agricultural use initially. So it is only looking at that top couple feet and whether or not it's going to support crops. I mean, that's really what it's looking at. We use it for much more. It's a wonderful, wonderful resource, and it is a great first step. But without going out there and actually looking at the soil and doing a test on it, we don't know how that water is going to move through the soil. We don't know what the implications are. On top of that, we're going to grade this site. We're going to be moving dirt around. So we need to look at the dirt that's going to be beneath our system, not just that top few feet. So in my opinion, if you don't do any field data you don't go out there and look at the soil and have someone out there look at it, then you need to assume that it's not going to infiltrate or that it's going to infiltrate super rapidly. One or the other. Then you're going to put in a filter. You're going to build a soil filter because you don't know how that soil is going to treat that water for you or disperse that water. So you're probably, if you think it might infiltrate too rapidly, you might go ahead and put a liner in, and then you're going to tile it to make sure that water doesn't pond and it goes away. Okay, so you're going to design around the soil. You're going to basically, again, assume the soil is not going to work for you. I think that sometimes you're going to miss some opportunities. So if you take this for site, for example, if this native soil, if you don't know anything about it, and it won't drain, and you think it will, and you don't put in your overdrain, then that water is going to back up. Does that make sense? Yes? Or if you think this is going to hold water for a certain period of time and support water-loving plants, but it infiltrates too fast, then it's, then you're going to be in trouble too. You're going to be planting all these plants that love water that don't have, there's no water there. But soil can do the work for us. Okay? Soil can infiltrate water. It can let that water, it can take on that water. It can also treat nitrogen. It can treat phosphates. It can treat bacteria. So we should let the soil do the work for us. If the soil can do the work, we should let the soil do the work for us. So, just like a natural system, just like our wetlands, just like our vegetated swales, is that water is going to go in, it's going to slowly infiltrate into the soil profile and slowly make it to the stream. This is great for the talk earlier today when it was talking about no runoff, right? Everything was being infiltrated. That is, kind of the ultimate goal. If you have the adequate soils for that, to let that water slowly get into that groundwater and reach the streams, that's going to give you better flood retention than if you're going to pipe this right to the creek. So in my process, when I go out to a site and we're looking at a BMP option, my first thought is, will this site support a soil-based system? Okay. Will that soil infiltrate? Will that water move through that soil profile? If yes, then I do my soils analysis. If no, then will it support what I'm going to call a non-soil-based system? Okay, a filtration system that has a discharge that doesn't infiltrate. Will it support that? If so, then build that. If not, choose another location. Okay. The reason I put this up there is because I was working on a project where literally the BMP would not fit on that parcel of land. And yet they were trying everything they could to make really steep slopes, pull it into the parking lot, trying to get something to fit in there that didn't really fit, wouldn't really work, wasn't sized adequately. But they really wanted it on that piece of property so they could get more parking in. And if it does not support the system, don't put it in, because then you're going to end up with a failure too. When we analyze the soil to determine its infiltration, we want to look at that soil profile 5 feet below the bottom of the system, especially on these larger systems like a constructed wetland. So you can do that with soil pits or with coring, any technique that's going to allow you to see not only the soil structure, or not only the soil texture, so if it's sand, silt, or clay, but also the soil structure, which is kind of how that soil breaks apart, whether it breaks apart in clumps or in columns, because that'll also tell you how water moves through that soil. There's several charts out there that you can look at from EPA, from surrounding states. I think the Iowa manual might have some numbers for infiltration. So, you can look at those, see to get, again, how fast is that water going to move through the soil profile. You can also do a double ring infiltrometer. This is similar like a perk test. Again, it can give you an indication of how water moves through that soil. You can also do both and then look at all of that data and see how it goes. And then just remember that any site that is going to be compacted during construction is going to change. Anytime you're going to move dirt over a site, if you do that soil test there, you're going to change it. So you don't want to, if you're going to depend on a soil-based system, you really need to protect that site from any construction activities. So at Webster City, we did several cores out there and looked at the stratigraphy. We had an area here that was stripped during historical times, possibly for the railroad berm. So the topsoil was stripped off of that. There's an area up to the north that had the original soil on it, and it was actually pretty thick. It was really nice black dirt. And then there was this area over here we're going to call a low terrace, where sometime in geologic history, the Boone River would have been up into that area and took all of this material away. So I'm going to show you a cross-section of that. Okay, here's a cross-section. What we have on the site is, first of all, when you looked at the soil survey, it said that everything was sand and loamy sand. And when you look at this, this is glacial till with sand over the top, and then some fill material on top of that on this side of the parcel. And what we found when we went out there is that that water table is perched on top of that till and is fairly close to the surface, within a foot or two. As we move closer to the river, here the glacial till had been removed. And because of that, it was not perching water on top of it anymore, so the water table was 7 feet down. And the water table in this part, closer to the river, actually mimics the Boone River elevation. So as we move from a higher elevation, the water table is actually higher than as we go closer to the river. So what this is telling me is that if we're going to create a constructed wetland on this site, one, we're going to have water table we're going to intersect at the west end, but at the east end, it's going to infiltrate pretty fast when the river is low, and when the river is high, we're going to intercept the water table on the east end too. So, pretty interesting. Okay, so here is this, again, where the river was up here in geologic history and scalped it away. And then again, the water table on the east there is going to fluctuate with the river. Okay. So next, once we understand what the water's doing, we're going to do our hydrologic calculations. In the manual, there's great worksheets on stepping you through this process. It gives you reference information. It has you calculate it. It works out really well, so I'm not going to go through that. The other thing you may want to go through is a water budget. And what this does is you put in your precipitation, your infiltration data, your runoff, your evapotranspiration, where your inflow and outflow is going to be, and then you model how the water table is going to fluctuate from year to year and from season to season. So typically when we do this, we look at a wet year, a normal year, and a dry year, and we model again how that changes over the season. So across the bottom is from January to December, and the vertical axis is depth of water. And this is actually not for this site, I cheated. So, but it could show you that in a wet year when we model it, the water table would look like, would have depths varying like that during a wet year, during a normal year, and during a dry year. So again, you can model this. So once you understand the soils, the infiltration, you have your flow calculations, you know what volume you need, you know what you need for storage, you know what you need for water quality. Next, you're going to select your best management practice, what type of BMP you want, Some of that's going to be dealt with space, or again, what fits into your site, what makes sense. And for Webster City, we were looking at an extended detention stormwater wetland. So this has, the different colors are different depths of water. So anything blue is going to be, I'm going to say wet most of the time. And then in light blue, it'll be wet during wet times of the year. And the yellow color is more wet during, right after some rain events. And then green would be bigger storm events. So that would be our extended detention area. And the idea is that as the water comes in, it is going to infiltrate into the soil and again, work as a natural system, and then the water will go through the ground and make its way to the river. So there is an outfall for those larger events so that the water in the extended detention area is only there for about 24 hours. Everything else is going to set to infiltrate. Okay, so this is a cross section, and if anyone's interested, I can go over this in a little bit more detail, one-on-one when you look at it. But one thing of interest is that the red line is the existing grade, and the blue line is the proposed grade. So you can see we're not really modifying the elevation too much. What's controlling it is going to be that berm, and that the fact that we're going to cut into those stormwater pipes. So I brought this one up again. The gold bar on the end there is sort of the estimate of the berm height, and the black line is an average surface elevation for the wetland, which is going to vary by about 2 feet depending if you're in a pool area or a high marsh area. So again, you can kind of see how we're cutting into the sand and where the water table is. Okay. So next is the vegetation plan. So when you're looking at the hydrology and you're looking at your watershed and your water quality that's coming into the site, this is the information that I'm going to give to my landscaper, my person who's going to design my vegetation plan. This is the information they need so that they choose the right plants. And I think this is probably one of the most critical steps. So they need to know what the hydrology is for each of those different zones, and it's going to be the depth of the water, the frequency that water is going to be at that depth, and the duration that it's going to be at that depth. So how often will it be at that depth, and how long will it hold at that depth? Is this something that's going to be in water for 2 weeks? Or is this something that's just going to come up for a brief 24-hour period and then drop down again? Plants will adapt. Different plants will adapt to those two different regimes. So the hydrology is really important for the vegetation plan. Your light conditions, your substrate, and we're going to make sure we have good topsoil at the surface. What your adjacent vegetation is. So again, if you're next to a wooded area and you're going to be shaded out, or there's going to be weeds that might be issues, you want to know what that is. What your sediment load is. And in our designs, we like to have the sediment load dropped before it gets to our site, because cleaning out your BMP and disrupting all that vegetation is a maintenance hassle. So we like to have some sort of sediment trap. Either in a wetland system, you'd have a forebay that can be cleaned out. What your salt is, some plants are tolerable to salt and some are not. If there's any pollutants or toxins, what your nutrient load is. Again, some plants can do really well in high nutrient loads and some can't. And then if there's any turbidity issues. So all of those need to be addressed. So for this site, that's what we did. We went through each of those factors, and then this is what we used to come up with our planting plan. Okay. And then we also talked with the client and said, how much maintenance do you want to do? What do you want this to look like? How are people in your town going to interact with this site? Because I think that's really important too. If this is something in the outskirts of town, then you could go with something that could be a little more messy. Whereas if it's something that's in town, then you're going to want to make it a little bit more manicured. So Judith has already talked a lot about plants, so I am not going to go through that, but on this site we had a wet prairie, we have a sedge meadow, we also are putting in some native shrubs to anchor some things in, and then again we have these different zones, and then Chant also went over operation and management of these sites, which again is really important that you want that to be part of your plan. And then finally, our ultimate goal is how do you turn this into this? Something that you're going to want to have pictures of kids with butterflies and show people at a conference. So here's my contact information, and thank you.
Okay, are there,
And then Chant also went over operation and management of these sites, which again is really important that you want that to be part of your
any
plan.
questions?
And then finally, our ultimate goal is how do you turn this into this? Something that you're going to want to have pictures of kids with butterflies and show people at a conference. So here's my contact information, and thank you.
Okay, are there, questions at all?
Because soil scientists refer to them, I mean, they're very similar, and yet they're different. I want to comment as well. In the world
So yeah, if you heard that, the question was using the term infiltration from water across the surface and then percolation as it goes down into the profile. And the other thing I guess I just want to add to that to understand is that water is going to move differently under saturated conditions compared to unsaturated conditions. And so again, sort of understanding that in your design too will be really important. So.
Yeah, so what you discussed now reminded me of installing.
If you heard that, the question was using the term infiltration from water across the surface and then percolation as it goes down to the profile. And the other thing I guess I just want to add to that to understand is that water is going to move differently under saturated conditions compared to unsaturated conditions. Yeah, so the question is, and I think I'm paraphrasing this right, is that this seems very similar to designs or site evaluations for on-site wastewater treatment systems or septic systems. And it is. I mean, it's really a very similar process. And some of my background was in that too. So, I mean, the idea is that you're going to calculate how water moves, how fast water can move through that soil profile. We do the same thing in septic systems. With wastewater, the wastewater is going to have, especially if it's untreated, it's going to create a biomat, and that's going to affect your movement through the soil. But this probably isn't going to create a biomat, but it's a very similar process as far as your site evaluation goes. I mean, it's really a very similar and estimating percolation. Was in that too. So, I mean, the idea is that you're going to calculate how water moves, how fast water can move through that soil profile. We do the same thing in septic systems with wastewater. Yes. So the question is how compaction would affect construction, or how construction would affect compaction of the soil. You know, when we would do wastewater systems, if a site was compacted, you couldn't put a septic system there because there was too big of a risk. In reality, it really depends on the soil. If we looked at the talk earlier today, they were putting in infiltration systems like next to roads, and you know that that road base would have been compacted at some time, but the soil in that area is very, very sandy, and that compaction of sand isn't going to collapse the soil structure as much, so that water's still going to pack through the soil in a predictable way. Whereas if you had a silt loam where it originally had some really nice vertical structure to it, and then you compacted to it, that water's not going to move vertically anymore. It's going to move horizontally, and then you're going to end up with a backup. So I think it depends on the conditions. Would have been compacted at some time, but the soil in that area